Um, Now we are going to talk about databases. So what happened was in two of the interviews in system designs, it's very important to have database knowledge, and I felt that I'm lacking a bit of it. So I decided to learn few things and then teach on YouTube or tell on YouTube so that I also remember it. And so, without further ado, let's start about the databases. So, what I'm going to do is I'm going to draw a few things here. Okay. Uh, yeah. So, let's say date databases. Okay. And now, uh, there are actually three types of databases, but I'm going to talk about only two today. Uh, and third one, let's keep it for like some maybe once I understand it in detail, I'll talk about it. So first one is uh, relational or SQL. Many people call it like SQL as well. And another one, uh, let's take another. Oh my, come on, what is happening? Same color. Now I want to have another here, but I want this color to be changed, but it's not changing. Okay. Uh, yeah, yeah. No worries, don't worry. Yeah. So another is NoSQL. Yeah. So from from this design, right? Uh, we understand that these are the two main, and another one is time series, but I'm not going to go into that. So now let me write down few things for relational database. Yeah. Uh, I don't understand the colors. Okay, let's keep this. Hmm. So relational means uh, there is a structure, SQL or structured query language. We say that, right? So there is a structure. First point is like there is a structure to data. I'm not good with spelling, so just ignore them. And it's kind of a rows and columns kind of a structure, uh, tables, right? Sometimes rows are called as records and columns are called something else, but you get the idea. And then there is another thing. You have multiple relations between uh, tables. So what this means is there is a student table and you have relation with address table with some ID, right? So these are the main things in this. So now the question is when to use when you are in a design interview or you are designing something, when should you go for relational or SQL database? Right, that's the question. What kind of a design when you're designing system? What kind of a Uh, in that case, in when will you use relational? So with before that, you are you aware of acid term, like, so it means like atomic, um, then consistent, then isolated, and durable, or durability, let's say. uh, okay, I think it's very important that we talk about this as well, just in one line, so that uh, if you come across this somewhere, it's you know that. So atomic means one or nothing, to be short. Uh, what this means is, if you are doing a transaction, it either succeeds or fails. There is no in between, like half of the transaction is done, half is failed. Not, no, no. Either the transaction is fully successful, or it's completely failed or rolled back. Uh, that's atomic property, consistency, right? Now, what this means is, um, how to say, it's not inconsistent, to be cheeky. So the data uh, when accessed is in correct state. So if you add a student with value as 100, student ID as 100, and his record, then whenever you access the 100 ID record, it should always give you that student. But if you, let's say, updated the 100th record to something else, then that updation has been done. So now, after that happening, that it should always give the updated version. It should never give you the previous version. That is called consistency. So whatever you add, you should get only that. You should never get something else, in to be um like simple, in simple terms. Isolated means, let's say there is a transaction T1 and T2. So these transactions are updating some data or adding some data to same table but at different locations. So these T1 and T2, right? They uh, should should work uh, independently. Uh, do you get what I mean? Like, it should not affect T1 that T2 is doing something, or T2 that T1 is doing something. At least this is what I understand. So isolated means there are multiple transactions, they should not conflict with each other. If there is a conflict, there has to be some mechanism to uh, wait for till transaction one is complete or something. Uh, that is taken care in SQL databases. So yeah, I think I'm going into NoSQL. That's why I might need to do this. And durability means, let's say, power failure or network error. Yeah. But before this, whatever the state of DB was there, it it remains same. So once the data is in your SQL database, once the transaction is complete, no matter what happens, it stays in that state. uh, the transaction is done, so you cannot say that this transaction never happened. Once you get a message that transaction is successful, that means it was successful, and you can always confirm that with the database. There is no problem with that, even if power failure or network error happens. So yeah, that's kind of my understanding. Obviously, there are some in detail, like you take a CS course on these things, right? So I'm not going to. I don't even know in detail. So I'm telling you what I know, and I think this is enough. Yeah. So I talked about this. So the question was when to use SQL, and uh, so you understood the ACID, right? So when you want ACID properties to be applicable, in that case you should always go to SQL, because by default SQL is ACID compliant. Okay. Second is if if uh, if you find data is not changing and structure is not changing, right? In this case as well, you should go for what is happening, man? I cannot show this. Come on. Okay, let's yeah. So yeah, in that case you should go for this one, and okay, yeah, it's cool. So we are here right now, and yeah. So also one more thing is the relational databases are stored in disk, right? And you need to access them and multiple times. So how to make it faster? So there is a concept of indexes, and if you want to have like faster retrieval of your data, indexes is really important to mention in your interview or in your design. So what is index? So basically, if you have a table, most probably your primary key, which is unique and not changing, can be your index, okay? Or it can be a combination of columns, UMNS columns that that are frequently queried on, like so if let's say again student, if you're constantly accessing data with the student age, it's better to have index on age column. And um, so now there is a little bit advanced concept that I found out. So I will give a brief about it. So let's say you want to have index on age. But what does that mean? So your query is like, give me the students whose age is between 10 to 15, or 17 to 20, or greater than 21, something like that. So what does that mean is, it means is you are having some sort of order, and you want it to be given in that order, or accessing by order is going to be really fast. So once you go to index, let's say you want to get all the students about 21, right? So you once you find the record of 21, then it's easy. About after that record, all the records will be in your result set. So that is one kind of index. So in that case, the index should be like B tree or B plus tree. So it's not like it's kind of a it maintains some kind of order in indexing, and you can I don't know in detail about these two things, but I think you can check it out. I know the basic is similar to binary tree, but it has not just two values, it has a list of values in B tree and multiple pointers as well. So yeah, but let's say you have a student ID which is unique per student, and you want to have index on that as well. So give me the student record of let's say ID 100. So in that case, this kind of a index, right? This kind of index won't work that well. So let's say if we have the student IDs from integer, in that case it's fine. But let's say it was some alphanumeric value. So in that case it won't work, right? It again has to go sequentially to something. So in that case, there is some another index, kind of index, that's like index for, let's say, uh, ID. It should be of kind of a hash index. So what it means is just let's just have a simple hashing function that maps to some bucket, and in that bucket there is the record or pointer to the record on the disk. So that's the basics of indexes, and I don't think it's required in an interview, but having some knowledge about it is a good thing, right? Um, yeah, so now I'm going to go to NoSQL without any further ado. That's how people say, right? And yeah, so here now in NoSQL there are like multiple things, and I'm not going to talk about them in detail, but just just to have this diagram, uh, I'm going to have them here. So in NoSQL there are different um, types of databases. First is key value. Why the color is never the same, man? Oh, okay. Uh, it's key value, or let's say another type is document store, or another type is wide column or columnar, and another kind is um, graph database, graphs. So these are kind of types of NoSQL. So basically NoSQL means there is no structure. So how many types of no structures can be? There can be a structure of key values, or a document, or a wide column, or a graph. So I think I should not write things because it is taking some more time. I will just mention it in short. So key value is like is kind of simple. You know that key maps to a value. That's it. Here it's mostly used in caching. So Redis and DynamoDB are examples of this key value. Okay. uh, mostly used in caching purposes. Then there is document store. So this means that again there is no structure. You have documents that are stored in a collection. So let's say a student has some properties, address, age, something, something, and uh, another student doesn't has something. So it's fine to store that in NoSQL. But in case of SQL, you will have that column in database, but there might be no value. But in document store, you can have any type kind of a document. It the structure can be same, can cannot be same, like there can be some minor differences, or it can be totally different structure. So it doesn't matter in document store. So documents structure doesn't matter. That's kind of it. A wide column, and yeah, about this, I we have like Mongo, right? MongoDB and Couchbase. These are two examples of this document store widely used. Wide columnar I have never uh, used in my personal or in my experience, but it's pretty common, I think, in interviews. So wide column is like what I have read is uh, you have rows, see, and you have columns, and but the columns are basically not just a single column. It is combination of some multiple values, combination of multiple values slash columns. Yeah, so that's kind of it. Um, Example is HBase. I don't know what is this, but yeah. And another is Cassandra. Never used it, but yeah, it's good to have. A graph, I don't think there is anything to say about it. It's kind of a use in social networking or that kind of design. Basically, you have entity, then uh, the properties of that entity, and you have links to another entity. It's kind of a graph, kind of a database. Example is Neo4j, and what one more, yeah, um, infinite graph or something like that, but not sure. Neo4j is one. Yeah, and on the databases there is another section, another type. So there is one SQL, NoSQL, and there is another database, time series databases. These are used for like time series uh, data when you care about these past 24 hours of data or something like that. In that case, this is used. I don't have much knowledge about it, so I'm not going to talk about it. But yeah, so let's say how can I yeah, so that's it. Uh, so just to brief again, there are three types of databases: relations or SQL, NoSQL, and time series. In relation, there is structure, rows, tables, rows, columns, or tables, relations between them. It is ACID compliant by default. What is ACID? You know this: atomicity, consistency, isolation, and durability. When should you use it? When you want everything to be ACID compliant. Mostly in banking systems, you use that. And uh, let's have a let me give you an example. So if you are designing let's say service for authentication purpose. So so you take a username and password, and you get an encrypted password. You unencrypt it, check it in the database, and return if it is valid user or not. So what do you think? What kind of a database is used in this case? NoSQL, key value, document store, wide column, graph. Two of the things that could come to your mind is like key value or relational, right? Um, yeah, both of them can be used, but the data is not changing that much, and there is a fixed structure. So in that case, it's better to go with this one, ACID. Um, sorry, SQL, and it makes sure that it's ACID compliant as well. Yeah, and indexes, in that case, you will have index on the username because you just want to record with that. There is no use of this B tree or B plus tree index, right? Yeah, that's about SQL. NoSQL, there is no structure. That's it. So when will you use it in that case? Yeah, I forgot about that question. When will you use it? Let me just write it down. Um, when NoSQL is used, when should you use it, right? So basically, you should use it when there is no um, or less structure, and second, scaling is IMP, right? And rapid development. So why these points are valid? Because here you have to design the databases, you have to normalize them, you have to separate data into multiple tables. But here, for rapid development, you just have a document store and you just put any kind of data in that, and it will start working with just if else cases in the code. Second thing, there is no structure. In that case, you should use it. Obviously, you cannot use SQL because the structure is not defined, right? So it's better to go for these kind of things. And third thing is scaling. Uh, so about scaling, right? Let's say you have a key value or document store. So if there is a limit to how much data you store on the disk, right, at a cache or on a server. So what happens is if if the storage is becoming full, right, so in that case you can have just a horizontal scaling. You can add another server, and new data you push into that server. So that's completely fine, and it is faster in that case. So scaling, uh, but if let's say similar case happens in SQL, then your database is like um, rows and columns, right? So when you want something by ages or something, you cannot have data on different servers. If you can have it, but it will be like you have to run the same query on each of the server to get the data, and the data will be different on each server. So you join it and then return it. Instead, it is when you can go for like vertical scaling, adding more space or more computing power. In that case, you should go for, means you should relational database is good, but that is really expensive. So if you want to scale but you have like limited resources, or ideally it's good to go for scaling, and scaling is important, go for NoSQL kind of a database. This is what I've learned online and stuff. This is not my expertise. I'm pretty sure there will be some issues in that, but I think this is like pretty good understanding of databases to be um, to know, to be able to have a discussion with the interviewer on the topic of database. So that's it for today. Bye.